coding in Swift, you typically have the same expression on your face as these people running this code, but not always. And this talk is primarily about the times when you are maybe frowning a little and you are coding in Swift. So, but before talking about Swift, let's talk about Objective-C first. Objective-C is a relatively old language. It was introduced in 1986 in this book, this particular book. It was written by Brad J. Cox. The other co-inventor was Tom Love. And this book is now 30 years old this year. So we are using a language that has as much history as C++ does in a programming language. This is a significant history. What's even more interesting than that is that just 3 years after Objective-C was initially introduced, we had the very first operating environment that was entirely based on Objective-C. Now, Swift was introduced 18 months ago in this book and during WWDC. If this precedent holds, then in 2017, which is next year, we might get something during the WWDC that will be interesting. We will see. There's a good chance that something will happen next year because Swift will grow up, as we will see. It will mature enough for Apple to do something interesting that's Swift only and don't grow the head of it in order to grow up and mature to be really usable as a development environment. You don't expect a baby to start coding to join your development teams, and Swift isn't ready for production use really yet. But that doesn't mean that you should not use Swift. You should. Even though it's completely unusable in its current state, it is still much more fun to use than Objective-C. So for isolated parts of your code, perhaps your unit tests, perhaps the tools that you use to develop your product, like asset management tools or localization tools, I think you should rewrite them in Swift right now. And if you have a module in your product that you don't mind having to rewrite every single month, just choose one and rewrite it in Swift. It's worth it, because you have to prepare for the time when this baby grows up, and suddenly you have to develop for Swift in order to survive in this ecosystem. Let's get over the most important, the most annoying thing first. If you ever write any kind of non-trivial Swift code in the current compiler release, you will meet this nice dialog. The nice thing about this dialog is this is popping up while you're typing, and it very nicely takes over the input focus. So I have about 200 of these crash reports from the last 30 days. Each one of them includes just a snippet of little code that I try to type in right now.
Have you tried Emacs?
Yeah, I tried. It's not ideal for Swift development. I don't think code completion is there yet. But I'm a great fan of Emacs, actually. Yeah, I will probably replace it soon. So this bug doesn't come alone. It will repeat itself pretty much on every keystroke you try to type in. But you know what? This isn't a real issue. This is fine. There is nothing wrong with this. This is a new language that is trying to move fast by breaking things. The Swift compiler was written in C++, but this is not the reason why it's crashing. The reason it's crashing is that there are invariants that were true when the code was initially written, but the language has evolved past those invariants, so the compiler reaches something that should be impossible. And the only reasonable thing to do at that point is to crash. You definitely don't want the compiler to miscompile your code. That leads to horrible debug sessions that could take days or maybe a week. And you know, it's much better to have a short, painful, but at least trivially worked around compiler crash. And this situation will not hold for long. because last month Swift has been open sourced. So if you are annoyed by these crashes, you are free to just go to GitHub, download the compiler, find the problem, fix the bug, create a pull request, and by the next release of Swift, your crash will hopefully be fixed. I really hope I don't have to do this myself. There are a lot of Swift developers out there. I think everyone is annoyed by this problem, and crashes aren't so hard to fix. So I expect the first release that comes from an open source Swift variant, which will come in this spring with 2.2. I think the stability of the compiler will improve, and most of these crashes will disappear. Not all of them, but most, hopefully. If not, we will have to dive into C++ code. Ugh. Okay, meanwhile, so this is the first and foremost thing that you have to get used to when you are using Swift. You could use VI or Emacs. There's nothing wrong with that. Actually, the Swift compiler team uses Emacs and VI internally. They aren't using Xcode to work on Swift for some reason. But you will have to give up a lot of things. Now, let's move on from this to something that's a little bit closer to the actual language itself. Let's talk about the type system as it's currently implemented in Swift. There are a couple of wrinkles in the current implementation that can lead to surprising effects. Like, for example, optionals have this overload for the less than operator, so that you can compare optionals as long as their wrap types wrap type is comparable. So, for example, since strings are comparable, you can compare an optional string value, for example, nil, to another optional string value, for instance, this Swift string. The result, by definition, is true because nil is supposed to be less than every single actual value there. No problem. If you try this in the current compiler, you will get the correct result. This overload is not the best thing, the best idea that ever happened. It can lead to surprises just by existing, because some APIs return a string, an optional string. If the API was changed to return an optional value, suddenly you might compare an optional to something that was not an optional before, and there will be no compiler errors catching that. But this buglet is not about this. This buglet is about comparing various things with nil. Let's see 0. How about you? What happens if you compare nil to 0? Is nil less than 0? Yes, obviously, the definition says that nil should be less than 0. How about a floating point number? What's the smallest floating point number that's representable? Well, that's the representation of the negative infinite value. What happens if you type this in? Well, nil should be less than everything, so it's true. Awesome. Now, how about what happens if you try it with a positive infinity? Well, obviously, this is a type error. Which is kind of surprising, but the real surprise here isn't that this is an error. The real surprise is that the previous ones were errors. If you think about it, double.infinity is a property that can never return nil. So what are you doing comparing it to a nil value? And it should be a type error, no matter. This is nonsense. So there's this implicit conversion between values and optional values, which can lead to a wrong place. In this case, the error message is misleading and nonsensical. If you swap the parameters and compare double infinity to nil, the other way around, you get a better error message. The actual problem here is that the property that you are using cannot ever be nil, so you shouldn't compare it to it. The first two items use literals, which can be upgraded to optionals freely, implicitly. On the other hand, nil is an unspecified type. It's some kind of optional type. It wraps something. It can wrap anything. It's undetermined. So the inference engine inside Swift decides that nil should be upgraded to an optional string. Meanwhile, the string literal should also be upgraded to the same fix so that they can be compared. There isn't much trouble with these first examples. The last two are complete nonsense and shouldn't be allowed by the compiler, but halfway it does allow it, leading to strange issues. Another related problem is this piece of code. You tend to try these kind of expressions out when you first learn the language. You sit down before an interactive Swift prompt and type in expressions to see what their value is. This is not something you actually usually type into an actual Swift production code, but you can try it out if you like. Here we declare a string value that contains a decimal representation of an integer, and then we create a 3-member array using this literal syntax, which we are filtering and only keeping those members that are not matching the integer value stored in this string. This works fine, there is no error in it. The question is, what do you think the type of X is in this example? It's a collection, very good. What kind of collection? What?
Inherited from collection.
Yes, of course. It is actually an array. The problem here is that it's not the array that you expect. What you would expect to happen is that for this expression, you have the value of an array of integers, right? Because you started with an array of integers and you're just filtering some numbers out. But that's not what's happening. The type of X here is an array of optional integers. There is this extra optional level that shouldn't be there, probably. How the heck does it get there? Well, this is a wrinkle in the type inference engine in Swift. If you look closely to this initializer here, this takes a string and converts it to an integer. That's a failable initializer, which means that it returns an optional value that can be nil. But since we aren't defining explicitly the types anywhere in this expression, the inference engine looks at the right-hand side of this comparison. Okay, it's an optional int. So the left-hand side should be an optional int as well. And how can it make it? How can it make this left-hand side an optional integer? Well, it just assumes that I was intending to create an optional integer array using that literal syntax. This is a surprising interaction between the inference engine, the literal convertible feature inside Swift, and probably there is some overload resolution sprinkled inside of it. This is something that sometimes you run across when you are developing actual Swift code as well. The symptoms might be a little different, but the underlying cause is the same. The fix is quite simple. You just declare the type that you want to use and be done with it. It's really simple. Again, one of the underlying components is that nils can be compared to non-nil values, or optionals can be compared to non-optional values, which is convenient sometimes, but sometimes leads to these strange results. The good news is that the entire type system inside Swift is going to be cleaned up for the third major release, which will come later this year. And along this cleanup, the inference rules and all the minute details about the Swift type system are going to be written in stone and simplified so that they can be understood while you are actually writing your code. The end result is probably that you will get less surprises when you are writing your code like this. Another source of errors is the impedance mismatch, or just the mismatch between Cocoa APIs that Swift is relying on, or that you are trying to use, and the built-in Swift types that can sometimes interact with these APIs. For example, string and NSString are pretty much interchangeable in Swift, even though that the native Swift string type is a value type, while the the NS string is a reference type, and those two are completely incompatible concepts. But still, it works most of the time pretty transparently. But sometimes you run into some strange API defects, like if you look into hashing, Swift has a native hashable prototype that allows you to express that your custom types should be hashable. It contains a hash value property. As it happens, NSObject also contains the same feature, but it's called hash. So there are two different properties that can provide the same functionality. Thankfully, they provide different values if you try to actually use them. This is by design, actually. Even if your string is backed by an NSString instance, Swift deliberately changes its hash value, not to mislead you into thinking that the two are the same. This is not the best API design ever. This is an inconsistency, something that you get disgusted by when you first run across it. But hopefully it will change. One of the other headlining features in Swift 3 is going to be a complete API redesign. Pretty much every single Swift API you use today is going to be renamed for the third release, including the APIs that are imported from Cocoa, which is kind of a big deal. Here's an example from the proposal text. This is UI-based path today. This is what it will look like by the end of this year. It's a completely different thing. It is much more convenient, much more Swiftier, but it will need changes in your existing code over rather large amount of changes, actually. Another interesting thing that they are going to change is they will drop the NS prefix from most types. So NSObject will probably become just object, which is cool. It feels a little naked to our eye today, but we will get used to it very soon, I think. By the way, this probably means that this meetup needs to be renamed next year.
I will be the happiest person to refactor the meetup.
Awesome. Okay, so another thing. So all of these issues that we talked about so far have been just little wrinkles, growing issues that the language will grow out of. The next two things, which will be the final things in this talk, are by design. And these will be much harder to change as the language evolves, because initially the language has been designed with these features intentionally, and changing them will be a huge drastic change, not just a renaming, but it will mean that we will have a completely different language. So one problem met is this concept of copy on write semantics. Most Swift collections are value typed, so an array is an array. If you copy it to another variable, you get another array. In order to make this performant, Swift implements copy on write semantics, which is usually abbreviated CAL. What CAL means is that this is the canonical example. You create a large array. When you modify that array, you mutate it by changing a single slot in it. That assignment is almost free. It's a constant time operation. However, when you then go ahead and copy that array into another variable, which you keep around, and then try it again, the same assignment, no change in the source file, what you will see is that while the initial assignment took a constant amount of time to execute, the other one is a million times slower because it has to copy the entire backing store of the original array in order to prevent B from changing. So this is fine if you are just worrying about the correctness of your code. It is much easier to write correct code with value-typed collections than non-value-typed collections. However, performance can be an issue, and that's, there is a huge difference between a constant time and a linear operation. If you convert your operations to linear by accident, that can make or break the entire user experience of your code. And you can definitely do this by accident. I did last week. I'm implementing as a side project, the 5 million size project. I'm implementing comparable collections for Swift with the same copy on write value semantics. And one thing I noticed is that red-black trees, which is the canonical thing to implement these things, are kind of slow compared to the n-squared array-based, sorted array-based orders collection implementation. So I got thinking and realized that maybe B trees are the answer. Today's computers are like computers 30 years ago, but their main memory is like the hard drive was 30 years ago. So the data structures that were designed for slow hard drives in the 60s, 70s are now relevant for the main memory inside your computer. So I actually measured this out. B trees, in-memory B trees, are 6 to 7 times faster in Swift than anywhere else on a modern computer than the in-memory search tree algorithms that you used to learn in school. I also noticed with my initial B tree implementation, which involves a lot of nested arrays, arrays inside arrays, is that I accidentally created an extra reference inside one of my routines, which meant that an append operation, which is supposed to run in constant time, suddenly duplicated an entire array every time it ran. And that completely ruined my entire graph here. B trees were about 2 or 3 times slower than red-black trees, and they were not even comparable to sorted array speeds. Okay, generics. How can you solve this, by the way? You really can't. There is no easy way to prevent this from happening or verify that it isn't happening. The only 2 things you can do is tapping into your program, instruction by instruction, to see if there is a loop there. That's kind of manual labor. The other option is to do benchmarks like this to see if the actual performance characteristics match what you expect. Neither is quite present. So the best approach for these kind of high performance data types is to just get rid of these copy and write collections and draw your own. Swift provides all the tools necessary to create your own array. And if you have your own array, you can just verify that it is actually unique when you expect it to be unique. Another short thing, I will not discuss this too much, but Swift has a parametric type support, which is based on Java and C# generics rather than C++ templates. And this has a direct effect on the execution time of your program if you are using generics. This is not something that you need to worry about unless you are writing something extremely specialized and high performant, like a big integer code. Big integer algorithms are usually expressed in terms of a abstract digit type, which is usually the word type of your computer, but it could be a decimal type, a decimal digit type if you're trying to do decimal begins, or it could be begins itself if you are trying to represent polynomials and express polynomial division and things like that. So when I was writing this module, I realized that it would be more useful to replace the specific and non-generic big unit type with something more generic with the exact same code, just replacing digits with a type parameter. This worked fine. I didn't have to change anything. It compiled and ran just correctly. And it was awesome until I benchmarked the result, which indicated that the generic code ran 10 times slower, literally 10 times slower than the other one. The reason behind this is that in this case, these kind of operations, like this add with overflow, are going to get compiled into a single machine instruction. That's quite fast. On the other hand, in this case, this entire generic is going to be compiled just once and then substituted for each specialization. And the substitution doesn't involve a recompilation step. In order to make this work, this instantiation or specialization rather, is going to create a dynamic dispatch table for the digit type. So instead of a single machine instruction, I'm now going through an extra indirection that I don't need. There is currently no good way to get rid of this in kernel Swift. But the good news is it is possible to get rid of this indirection step. It is possible to make the Swift compiler smart enough to realize that this is the case and generate specialized code for each substitution. Or if that's not viable, the Swift compiler creators, or us if we were to do this ourselves, could just modify the compiler to add an inline attribute or something similar to the inline attribute, force the compiler to make this big num type work more like a C++ template rather than a C# generic. Okay, so in summary, Swift is young. It has some issues. It shits its diapers a lot, but it is still adorable and it is really fun to play with, and it is growing up really fast. Impressive how fast Swift is moving. So Swift 3 is coming later this year. I expect it to be released around December-ish. It's probably not in time for WWDC this year. Maybe we'll get a preview, maybe not. The most important headline feature of it is the stable API support. What it means is that you will be able to distribute your Swift code in binary form, which allows you to cooperate and use Swift code in a large-scale development environment where many people are working on the same code base. Because you don't have to, when you want to migrate to a new Xcode version, you will not have to upgrade every single line of code at the same time as once. So this is kind of important. The other important half of this is resilience, which means that frameworks starting from Swift 3 will be able to evolve independent of the code that is using them. So if you add a new feature to your framework, you don't necessarily have to recompile the client code that is using it. And this is absolutely essential for Apple, because without this, they aren't able to provide any kind of Swift frameworks inside the SDK. If this is in place, which will be by the end of this year, it will stabilize probably this time next year. And by this time, by WWDC next year, I expect that we will indeed get some nice little present. I don't know what that present might be. I'm not going to think about it much because Swift is still too early and there's a lot of things to do before that happens. But I assume there are teams inside Apple that are working on something interesting for next year. Okay, so thank you. I've overrun, I think, a lot. Wow. So I suppose the best thing to do is to not ask any questions, but wait for the next break and just ask the question for me directly. Also follow me on Twitter. I have too few followers and I'm lonely. Thank you.
So, thank you, Karen. Let me introduce our next speaker. And I'm just going to share some feelings because István is the guy who showed me iOS development in the university. So actually, he was my teacher. He's a nice guy. And he also made something really amazing happen. So he will talk about how they redesigned their 3D modeling app for the iPad Pro. Welcome.
So hi guys, I'm the founder and the CEO of Shaper 3D, and we are making a professional 3D modeling application for the iPad Pro, and exclusively for the iPad Pro. So many of you have heard my previous presentations on other meetups about the Shaper 3D architecture. So I've been trying to not to be too boring. So I will marginally talk about many different topics that are related to Shaper 3D, and I would love to answer your questions after if you are interested in the details of these topics after the keynote. So just a short introduction about computer-aided design and 3D modeling, about the state of this industry. So this is what other companies think how a 3D modeling software should look like in 2016. And it looks like in 1917, and that's because they didn't do too much about the computer-aided design user experience and user interfaces in the last 40 years. So the user interfaces and user experience of 3D modeling hasn't really evolved in the last 40 years. And we have a very different vision about this. We think that in 2016, 3D modeling should be mobile. It should be super easy to learn. It should be really intuitive. And that's why we started to work on this application. We think that a complete redesign of the computer-aided design user experience is needed to make it accessible for more people and bring this industry to the 21st century. So in this video, you can see the basic interaction that is using only the Apple Pencil and only multi-touch gestures to make your 3D modeling. We are not using any menus, any buttons or anything. It's only the Apple Pencil and your fingers. And so this is a basic interaction. It can create quite complex models without using any other 3D modeling tools. But we, of course, have lots of 3D modeling tools that can be accessed from the menu on the left side. And those are capable to do even more. So why the iPad Pro? That's a question that we often face. People are freaking out that we are making a professional 3D modeler for the iPad. And that's because they don't understand what the iPad Pro is. The iPad Pro is not an iPad. And that's a misunderstanding. The iPad Pro is not an iPad. It's an absolutely new device category. And that's not just because of the amazing processing power of the iPad Pro, and not only because of the amazing huge screen of the iPad Pro, but because of this amazing new piece of device that is called the Apple Pencil, that is actually a stylus, of course, but it's called a Pencil by Apple because they cannot have a stylus because of Jobs. So, so the Apple Pencil, if you haven't tried it, it's really fascinating. It's extremely responsive, and its responsiveness is caused by its event prediction. That's really awesome. So it can predict what is going to happen with the Apple Pencil, and you can prepare your application to use these predicted events to make it super responsive. And also it has pressure sensors and tilt sensors, so it can respond to tilts and pressures that you are making with your Apple Pencil. And its battery time is also quite amazing. So I'm using it 12 hours a day, and with a single charge, it works for 1 or 2 days. So it's a really great piece of hardware. And this bigger screen indicates lots of changes in your UI design. So when I say that this is a new device category, I really mean it. So a traditional iPad user interface scaled up to on the iPad Pro screen wouldn't work. Here's an example. For example, you can see that's the typical position how a user holds its iPad Pro. His smarter hand, in my case, it's my right hand. He's holding the Apple Pencil, and the other hand is holding the iPad Pro. If that application would be running on a smaller iPad, probably the menu on the left-hand side would be on the top because it works fine. The iWork applications have these menu bars on the top, and that's a perfect UI. That's a perfect user interface. But in this case, because of the bigger screen, it would be really tiring to always move your hand to the top of the screen. So we decided to move this menu to the left side, where you can easily access the most important functionalities of the app. That looks like a small thing, but it's super important when you are designing an app that will be used by people 8 hours a day. And the other thing is that you have to prepare for people that are not right-handed but left-handed, and there are people who are left-handed. So you have to make a left-handed user interface and a right-handed user interface. In our case, based on the direction of the pencil, we can detect that if you are left-handed or right-handed, and we are offering the user the opportunity to mirror the UI and switch to the left-handed user interface mode from the right-handed mode. So that's what we are making is a very special application, and and it requires a very special technology stack. Of course, you're not going to write your own 3D modeling kernel because that's one of the hardest problems in computational science. So our application is based on OpenCascade. OpenCascade is a very mature 3D modeling kernel that is written in C and C++. It's been under development since the early 1990s. Well, in previous meetups, I told a lot about OpenCascade because it's a very interesting piece of technology, especially because of the huge amount of legacy code it has. It's from the really early days of C++, when there weren't any templates, and there weren't actually any language features in C++ that we know now in the current state of the language. So, but despite of these legacy issues, it's a really amazing library. Its computational power is ridiculously great. It runs perfectly on mobile CPUs. So its price-value ratio is unbeatable, really. We wrote some extensions to this library in C++ 14, so it's when we are writing C++ code, it's usually modern C++. And based on these two components, we have written the so-called Shapers3 kernel that contains the application logic and the modeling algorithms. And on the top of that, we have a super modern 100% auto layout based user interface that is written in Swift, and we are using it in production environment. So, sorry, Karen. So, and our visualization is written in OpenGL, of course, because by the time when I started to work on this, we didn't have Metal, so so it is written in OpenGL. So it is written in Objective-C, GLSL, and Swift. So we are writing this application in 5 different languages. That makes the development actually quite fun, because when you are getting tired from C++, you can go and make some super awesome, super fancy Swift code, and when you had enough of making 1,000 UI buttons a second, then you can go back to the C++ code and make some really interesting geometric algorithms. So how we do quality assurance? Well, in this, so in computer-aided design, quality assurance is super important because people are going to spend a lot of money to manufacture those models that are created with your application. And if there are bugs in your app, well, it will cost your users lots of money. So quality assurance is extremely important. We have 2 important quality assurance tools. The first one is, of course, unit tests. That's of course, that's quite basic and not very interesting. But the other one is pretty awesome. It's called the Monkey. Many companies are using monkeys, but there isn't any general solution for having a monkey. The monkey is basically a script that performs almost random events on your application and tries to crash the app. But our monkey not only trying to crash the app, but it also generates reproduction codes. So when it finds a crash, you can just copy-paste the generated code from the monkey's logs to Xcode, run it, and it will reproduce you the crash. You can fix the crash, and unfortunately, it doesn't submit a bug ticket yet, but maybe later it will. So it's a pretty awesome tool. And it's also great because you can measure the uptimes of the monkeys, and you can achieve huge quality improvements by setting up runtime milestones for your monkey by every week. Yeah, so that's all. If you have any questions, I'd be really happy to answer, or I will be here after the meetup as well. So, no questions? Okay, Carol.
How thick is your UI code? How many lines of code is that?
The entire app is currently about 32,000 lines of code, and the UI is about, I think it's 7,000 or 8,000 lines of code. So it's quite small. We are trying to keep it small. We are trying to keep it platform independent as much as it's possible. Yeah.
How do you interact with C++
It's quite easy. People usually think it's impossible to use Swift together with C++. We have a very well-defined interface in the C++ code, and we wrapped it out in Objective-C. And the communication between the Swift code and the C++ code is based on C structs. So the UI and the backend is passing C structs, and that's all. I didn't talk about that because in previous meetups I told about this topic a lot, how to integrate Swift with C++, but if you're interested, I would be happy to show you the code, so it's really not a big deal. Yeah?
Have you got any measurements about switching from OpenGL to Meta?
No, unfortunately, we don't have the resources currently to rewrite our render code to Meta, but I think in our case it wouldn't be huge improvement because what we do in the render code is quite basic. So it's not we don't use any super complex shaders, or we don't use any fancy OpenGL stuff. It's quite basic. Yeah.
How does your monkey script actually interact with the application?
It is written in Swift, so it is integrated to the application and can be turned off from time. Yeah.
Do you use any library for calling the geometry in rendering, or is it in-house?
No, it's absolutely in-house, but as I so it's not that our render engine is not a very big deal. All we do is just render a set of triangles without any fancy rendering logic or anything. So it's really not a big deal.
So that means that it's inherently limited by the throughput of the GPU if you're going for real complex models.
Well, the iPad Pro's graphic performance is really amazing. So we have been trying to use it with super complex models, like really super complex, like a complete engine or something like that. And it was running 60 frames per second without any problem, without any optimization, without even using octrees or any optimization. So yeah, it's amazingly fast. Okay, thanks.
Thank you. So my last speaker for today is Peter. He is the iOS lead at Skyscanner, and he is going to talk about how they scale the mobile engineering. Welcome, Peter.
Hello, everybody. So what I can see here is a nice pattern. First of all, we spoke about code in Swift. After that, we entered the realm of application development, and I want to extend this view to talk about a little bit about engineering and organizing and how we can produce code in scale. It's a little bit different topic, a little bit not the deep one. We can enter this, so we can okay. So we can talk about it later. So come at me and ask a question if you feel. So I choose this topic because I thought that I would like to give a little bit little interior tour of Skyscanner. And let's talk with this guy, me. So introduction, beside Agnes' one. Basically, I'm a little bit coding roadie. This means that I really like to hack and deep dive into problems, but I like to stay in the background, not this time. And also I'm an Ecoman. There is a really cool article linked in this presentation. It's about different type of characteristics and engineers you can find in your teams, and they are associated with different type of superheroes. There's a Flash or Spielberg or I'm an Aquaman. Basically, this type of character really likes to spend much time with finding out what is really a problem behind the code, spending nights and days about that. Actually, like it has a disadvantage that it has to go up to breathe because it will get drowned. Really interesting because the superhero can't actually. So what you can see in the title that I'm a senior software engineer, but if this meetup would have been held 1 year before, then I would I would write lead iOS developer. So between developer and engineer, I think there is a small gap, a small difference. It's not about the characters and the letters. It's rather that instead of using and working just with code and developing something, you try to be part of the production and focus your attention on more things. So to focus on attention more things and also to handle scale. So you develop and you try to write code to be and handle scale. What can scale bring to you? So let's meet the application that we are developing in Skyscanner. It's like the Skyscanner Flights iOS app. This slide is like basically about how complex is our job, given the fact that some statistic here. So there is like 40 million downloads so far. We want to support 30 plus languages because we want to reach a lot of people. We also like to be in 13 countries in the App Store, basically staging markets. But this means that we have to create 13 targets for every release. And of course, we have like an average of 15 plus million visitors across web and app. From this small statistics, you can see that there are a lot of users who are relying on to find them cheap flights. So this brings a requirement, a little pressure on us, and also gives us some example that we can mine some data and find out what kind of user we are dealing with actually. So what are the users, or what does the user use our app for? There are two types of users from what we could see. The first one is the one that already knows where he wants or she wants to travel. So this can be like a businessman who is traveling frequently to different countries, for example, or a head of tribes technology. So in the tribe, Ákos, for example, who is flying frequently to Scotland. And they have already chosen destination, and they basically try to find the cheapest flight. The problem that we want to solve here, that's like we are dealing with more than 1,000 global partners. And in this case, this application has to act like a Google Maps. So you know the A point where you want to go, the region from where you want to go, origin, and where you would like to go, the destination, and we should find the effective path between them. On the other side, there are users who doesn't know what they want to do with their the travel. So basically, they are collecting inspirations and information. In this way, it's not always about the prices, but about extra information they can use to decide finally where they want to go. So for example, weather, great articles on them. The problem what we want to solve is like, if you don't know the destination origin or when do you want to fly, then it's basically an anytime, everywhere combination. So basically a lot of dimension and a lot of possible outcome of that. So basically, for this, we like to collect like 1.5 billion codes and flights we want to serve, and we would like to show them. So these are the requirements. I put these slides in to give an insight how complex this problem can be. So we have to find something, otherwise we go crazy, and we would like to solve this problem. Then we want to, basically the main goal is to help these type of users. So if you want somebody to help, then you have to understand them. Basically, you have to shift your focus, what I mentioned previously in the develop engineer comparison, that you have to shift your focus from code to production. You have to have a production mindset. You have to start with the user and end in the Xcode, basically. And this means, and this happened to me a lot of times, that you have to find the exact good ways and solution that will impact the user more, and not just for own entertainment. There was a lot of things that I found. I thought that some module or some code is really awesome that I wrote, but it was useless for the user. So let's switch the thing and first think about the user and find what is best for him or her. So I call it data-driven development, aka I only will create this ticket or I only will do this ticket, Jira ticket, if it's really impacting the user or not. For that, we have to gather informations. Oh my God. And finally speaking in the microphone. So basically, there is two types where you can gather information. First is analytics. You have to dig into the analytics tools. We like to use more of them because more analytics tools and the different analytics tools provide different insight how the users try to use your application. So for example, Google Analytics is a really great tool where you want to find the sessions and how the user proceeds from one screen to other. Mixpanel is really cool for segmentation. And yeah, I could name other analytics tools, but these are like assumptions only. If you want to dig data from them, then you have to set up a mind model of the user and find out whether your assumptions were correct. And the other thing that you could use is to go to the user actually, or basically they're coming to us every week. So have a user testing and face your problems. Really interesting thing to see when the coders who are coding every day just sitting in a user test and they are like, oh my God, push that button, there is the button, why don't you push it? So it's a really interesting and painful for developers, for product owners and researchers, really great thing to see because they get instant and synchronous feedback how the users want to use their app and whether their assumption are actually correct. To support this user testing, we try to use prototyping. It's a common thing. Interesting thing that for prototyping, we actually try to produce production code. So it's like levering between going fast and going stable. Other thing that we try to use, but it's basically in the white, is that experimenting. Other thing that we have some mindset, we verified in the user test, we did some prototyping, but we haven't narrowed down the problem and the solution into only one possible solution, but two or more of them. In this case, we are actually using experimenting, for which we have basically a custom tool. So not to speak that the whole thing, what I mentioned here is basically researching on the users, digging the data, and there are special roles in Skyscanner who are basically researchers who are doing this. So this is a ways of working. This is the requirement what we want to have for ways of working. This is how we actually do it. So in Skyscanner we are working like in squads. This was introduced by Spotify. But if you don't know, you can access the link and you will have a really cool YouTube video about that, a two-part YouTube video. A squad basically, basically maximum 10 people who were designers and developers are already presented. Actually, maximum 4 engineers, 2 designers, 1 product owner, 1 tech lead, and 1 researcher. They have full autonomy on what they want to do, but they have to align together not to have full chaos inside Skyscanner. So they are collecting them and they are grouping themselves into tribes. So if the tribes and the tribes, of course, from more tribes there will be the company, and from them the company gives the goal. The tribes try to follow them as much as possible. But the tribe can decide how it will try to proceed. In the squad, for example, they have their own autonomy, but they also will try to align with the tribes itself. So, for example, what you mentioned, there are exploring users and file selection users. What I mentioned before, two sides is basically we try to solve this problem by assigning these tasks to separate squads. For example, I'm in the discovery and exploring squad. So we have the structure. We solve one problems in the scaling. So having two different things in one application. And after that, there's a really interesting thing. I don't know how many company has this thing, but designers and engineers are really trying to work together closely. They are sitting beside them, and not just sitting and talking, of course, but learning from each other. It's really interesting to see that when designers try to write code or engineers try to learn some design tricks, because these men, for example, for the engineer, that he or she can do some a design decision without the help of designers and still be aligned with the squad, or the designers can think of the UI in that way that it will be feasible. So we learning the hard way when creating design is really important that it should be feasible. When they're working together, they want to have fast iteration, what I mentioned, like in the form of prototyping, but they really try to focus on the MVP, the minimum viable product. This means that the squad should focus on and find out what is the most key findings and most important things to create first for the users. And yeah, a really interesting thing that we don't have QA. I never mentioned any QA in the squads. We have three. One of them sitting back in the back. They're a really rare species, but really cool. They're helping us maintaining bigger changes in the code base to testing that. But as an engineer, you are responsible for your code. As a product mindset people, you always try to focus on user behavior and user helping the user. This means that you should know what you wrote and how the user should test it. This means that we don't have any QA. We should put on our tester hats and test our own code, and we still have a lower crash rate than half point percentage, so 0.5%. So I think it's really interesting thing that moving so fast, prototyping, keeping the MVP, and still designing the QA to work on this. I lied a little bit because we don't have an internal QA, but we have an external QA in the form of testers like in Atlas. They working with our nightly build. This means the developer or engineer go home at 6 p.m. He pushes the code, final code to develop. He goes to sleep, of course, later, and then on different time zone, and other people are starting to test our application. And when the engineer comes back to work, he will find the Jira with full of crashes. So this is one interesting that we lead in, and it gave us a real big support to be brave and try to change the code heavily and move fast. Yeah. Beside this nightly testing code releases, we try to keep a 2-week release cycle. This is a really big pressure and really focuses on to not to break anything. Try to focus and speak with each other, because this deadline must be kept. If you are not on the release train, then you are left out and you have to think with the next release. I think this terminology and this thing is a very common other thing in other companies. And really important thing that once you release your application, you have your solutions or experiments. You have to maintain them, not leave them rotten. and focus on the next sprint. So there are like an overlapping sprints where we try to measure and evaluate the experiments we created. So we see the complexity of this whole application. We have some workflow. Let's give some tools that we can back up this requirement, these workflows. So first of all, let me go memento and go backwards. What we see here previously. Let's start on the back by providing this some insight how we are trying to release our application. So this is not big thing. Every startup, I think, or company has a release cycle or at least a CI. We like the engineers go to the Xcode and pushes his changes to GitHub. We're using GitHub. The webhooks are hooked to a special version of Jenkins. We can call it like a Jenkins++ because we wrote a little wrap around it to make it more convenient to use. And these things where the magic happens, so basically we finally, and it was really hard to think things to do, but we finally could make a full App Store submission release train, or basically a CI job. Other interesting thing beside an IT build, what I already mentioned, is that we try to use, of course, Git flow. I think this is a reasonable way to work in a big company, but also with a little trick. So when we're creating a GitHub pull request, we have some rules how, for example, features or bugs should be tested. But one pinpoint, one pain in the ass, was that you have to download the code, check out the branch, and build the application if you really want to do so. Not just code review. We are not doing only just code review, but really want to find out whether this pull request does its job or not. So for that, we created a small script that will create this build for you and upload for a container and provide you a QR code, and you can just snapshot it, and the tester or developer engineer can test your building on the wall, for example, or in the kitchen, so it's not bind with your desktop. Okay, so if we have release train, that the main point is not to block the release train. It's the number one rules of Fight Club, no? So enable this requires that you try to differentiate and change your application. Previously, we had a monolithic app. I think it's something that every project has, like we're starting from small and putting and pushing features into them, like and playing Django with the Xcode compiler in the background, because there is some point when it cannot handle anymore, and you cannot change code without blocking each other. So a logical way was for us to separate our features into modules, and it's not only for reusing code in different applications, but also to enable more and more 40 engineers to work together. So if you saw, I think already everybody saw a massive view controller in the code. Basically, one sign that you put too much feature into one component and you have to split up. It also means that you have to find the smallest dependencies that you can separate into different modules, and you have to minimize it to not to break each other. Interesting story is that this modularization helped us, this Harry guy, to make a whole application change like in half a day, impacting like 4 or 5 repos and other private repositories. So if you want to have modules for an iOS guy, Cocoa Pods is like standard way when you are thinking about modelization. So we also did that. The first thing you can see, this is only a scheme that you can see that we have different modules for every page that you can see, and in the previous video we try to have. We are in the meantime, by the way. And as you can see in the layers, we try to give some different abstractions. For example, a platform is for the abstraction where what every page would like to use. Core is something that you reuse in every application, and you can find some example here, analytics, localization, experiments that are really interesting modules. So we have a release train. We are not blocking each other. Now we want to reach more and more people to gather information. This was like one key point previously on my sites. So if we want to reach 30 plus language spoken users, then basically you have to have your good localization module. For us, the NS string and the NS localized string localization was not enough because we want to have cross-platform localization. We want to reuse some of the things that we previously translated. So we created an interesting localization pattern where every view can localize itself because we created a category on the UI view, and this localization handles all the registration for a special notification that will be triggered by a localization manager when the user changes the settings. The interesting thing is that we are not relying more heavily on the device settings, but we try to have our own custom language configuration. Okay, so you reach the users, now it's time to collect some data. Before we have a special analytics tool, I mentioned that if you want to have all the aspects that the user can use that and investigate them and build up that mind model, then you have to use more analytics. In relation of the MVC, like a massive view controller, we have really big problems about this because we put every type of analytics logging event in one place, in one method. So it was really easy to find 100 lines of code in one method because only because of analytics. You can separate it with other interesting pattern like MVP or MVVM, but it won't have the case because in this case you still want to some extra context. So this is a requirement. We want to believe that only logging UI interaction is not enough. We want to find out some of the context too. And if you want to do it in the first way, then you have to collect everything in the view controller or in the presenter. So this thing we changed a little bit. And when the user taps, for example, this title, we are using a bubbling pattern for every view, a view to collect its own context and aggregate together in a dictionary. And the final end of the change will be the app delegate, where a mediator will be called who will push these events and context to every type of analytics, like Google Analytics or Facebook Analytics, or for example, Fleurs. So these are really just some tastes of or tools that we are using. I did only 3 intentionally because I really want to talk about this after the thing, and if I tell everything in one presentation, then we can talk about everything after that. So there were I think mainly 3 topics that I wanted to, or key findings that I wanted you really to remember of this presentation is that there was a really interesting path when we joined Skyscanner, when we became engineers, or not became, or we stepped on the path. We want to become engineers, developers, by focusing more on the users and the product, what they really like to want from us. This small application, like the Skyscanner Flights app, hides really more big complexity. The travel industry and the travel field itself hides more complexity that you would think. And if you want to survive with 40 engineers, and if you want to enable more and more development of the project, you have to adapt to it. So this was me in short. Thank you for your time and your attention. On the left, you can find the asynchronous contact information. You can ask synchronously for me in the Q&A session if we have time. I can't see the time. And if you want to, if we somehow left out some tools in the speak and you're interested, we started an engineering blog. It's called Code Voyagers. You can follow us on Twitter. We share everything what we do, or we try to share everything what we do. There is a website, and if you want to be part of this scale, what we are set or foot upon, then you can join us under this link, jobs. Thank you very much.
Question?
Thank you. So I hope you enjoyed. I think first we have to thank our speakers for standing up and giving their presentation. You are awesome. And I hope the others are also encouraged to send some proposals to our GitHub page and talk at our next meetups. What's coming up now? I think we are okay to hang out for another half or more, half an hour or more. So please talk to each other. Thank our speakers. Yeah, literally in real life that they came to us. And also we thank Skyscanner and Linda for making this even happen. And yeah, thanks. Oh yeah, one thing. Later we plan to go to Simpla. So if you are interested, just join us when we leave. Okay, I think I will wait for the end of the party. So thank you.
Which one? Which Simpla? Melyik Simplába?
Simpla Cat,
Simpla Kert.
Kazinci Street.
Oké.
Okay.